This is Algebra 2, Lesson 13.1, picking up on part number 2, solving right triangles, example number 2. It says solve triangle ABC. Angles A and B are complementary, which means that they add up to 90 degrees if they're complementary. Supplementary was that other word you learned. Supplementary means they add up to 180 degrees. So it says A and B are complementary. So A is equal to 90 degrees minus 68 degrees, which is equal to 22 degrees. Now, these numbers come from the fact that since they're complementary, 90 minus the one you know, which is 68, that's angle B up there, gives you angle A's value, which is 22 degrees. Most students don't remember or don't think about two angles being complementary in a triangle. Most students simply remember that they add up to 180. Where the mistake people make comes in is they start thinking, well, is it 180 they add up to, or is it 360? That's where the mistake comes in. That's where the confusion comes in, I should say. And the reason students do that is because we know going all the way around in a circle is 360 degrees, but also when you add a side to this, when you make a quadrilateral or anything with four sides, it doesn't have to be a square or a rectangle. Anything that has four sides, it's going to add up to 360 degrees. But a triangle is simply 180 degrees. So solving this right triangle, we have side B divided by 5 is equal to the tangent of 68. Side C divided by 5 is equal to the secant of 68. Notice uh, we didn't change which sides we were looking at. We looked at B and we looked at C, but we had to use that value 5 over there. We're going to come up in a second with this value A is equal to 5, but right now we don't know, we know that A's value is 5. That's the only value that we have is 5. So we have to use that one because we don't know what B and C is. So what that means is C divided by 5 is equal to the secant of 68. Remember what the secant of 68 is. The secant of 68 is paired with the cosine. So it's just simply 1 divided by the cosine of 68. If you look on your calculator, you don't see secant and cosecant and cotangent. You don't see that on your calculator. What you do see above those keys, though, is you see the inverses, the sine of -1, the cosine of -1, and a tangent of -1. You're not using those values for this. You do 1, you hit divided by cosine of 68, and it's going to give you that approximate answer right there, 2.669. You'll probably get something that fills up your entire calculator, um, and we'll round it to an appropriate value for that one. B then is approximately 12.38. That in 12.38 comes from the tangent of 68 degrees. All you have to do is hit tan 68, and you probably need to close your parentheses off, but you might not have to get 12.38. C's value is 2.699. Out here on the side, I'll write it what's going on right here. The 1 divided by the cosine of 68 gave us this. So what we have now is C over 5 is equal to 2.669. I said 699 a second ago. 2.669. In order to get C by itself, this says divided by 5 here. So just algebraically, we know we need to multiply this by 5 and multiply this one by 5 as well. So that's where C's value comes from. 13.3 is an approximation for that one. 2.669 times 5 gives us 13.3. So on the back, it says find the value of x for the right triangle shown. We're only looking for one value. You need to use it from this perspective, 30 degrees, and you need to use this value here. We don't have any other values given to us. So take about 30 seconds to see if you can at least figure out which formula you should use. Remember, Chief Sokotoa should help you with this. So, and I always enunciate when I pronounce it to make sure that we know it's Sokotoa. Take about 45 seconds or so. Okay, let's take a look at it. You have to you have to realize spatially what you're dealing with. From this perspective, and I circle it for a reason, from 30 degrees, what does X represent? Is it, and there's three things it could be. It could be the hypotenuse, it could be the opposite, or it can be the adjacent. It's one of those three. Which one is it? It's the opposite because it's opposite 30 degrees. Also, another way to look at it is 30 degrees isn't made up with any of the sides. It's the one side that 30 degrees doesn't make it up. So it's an O. So it's an opposite over here. Also, you have to look at this perspective right here. From 30 degrees, what is 15? We know it's not the opposite because that's what X is. Is it the adjacent or is it the hypotenuse? Now, this is confusing to some students because we know what that word adjacent means. None of us use that word adjacent in our real life. But in math class, we know what it means. It means right next to it. That's all it means, right next to it. 15 is right next to 30 degrees. But in a right triangle, the hypotenuse is that special side. It's the longest side out of the three. It's the one that's opposite the right triangle, and that's what this one represents, the hypotenuse. So we have an O and an H. When you look at SOHCAHTOA, the only one with an O and an H is this one right here. So that's the one we're going to use. Sine of 30 degrees is equal to the opposite X over the hypotenuse 15. Okay, so that still doesn't tell us what X is. That tells us how to find X, though. Algebraically, how do we get X all by itself? It says X over 15, which means X divided by 15. How do we undo that? Multiply by 15. That's simple enough. Multiply this side by 15. And when you do that, you do it to this side over here. So now that simply says 15 times the sine of 30. So punch it in just like that. 15 sine 30. And you'll get it's an exact value. X then is equal to 7.5. Note that when you do stuff like this, oftentimes you're going to get something that is an estimated value. You're going to have to round to the nearest tenth, hundredth, or thousandth, depending on what the instructions say. If they don't tell you where to round to the nearest hundredth just as an easy rule, just to keep it the same as money. Okay, that's just kind of one of those rule of thumb things, rounded to the nearest hundredth. Okay, again, right next to that one or right below that one on the back, this one tells you to solve triangle A, B, and C. Three values are up here for you. We can see that angle value 62 right there. That one's easy to see. We can also see that side value 6. The one that people forget about often is C's angle value. What is C's angle value? 90 degrees. That's the one people forget about. We all know how to use it, but when I ask you what's given right here, a lot of times students forget that one's 90. So what we have is angle, side, angle, and that's enough for us to solve what the rest of them are. So right now, take a couple of minutes and see if we can solve for the other angle. That's the easy one to find. And then the other two sides. Don't use don't use something that you solve for to find sides B and C. If you don't understand exactly what I mean, I'll explain that as soon as you finish trying to do this real quick. Let's take a look at it. The easy one, the first thing that you need to understand is to find, since you have two angles given to you, again, 90 degrees being that second one with that box, we all know what that means. Find what the third one is. You know that together they all equal 180. On the example, we said that the two angles were complementary opposite, or the ones besides the 90-degree angle. If you can't remember that they complementary, which means they add up to 90, don't worry about that. Just remember that they add up, all three of them, to 180. So just do 90 plus 62, and you get 152, and then subtract that from 180. When you do that, you're going to get 28 degrees for angle A. Everybody should have been able to handle that one. 28 degrees for angle A. And again, that's putting all three of them together, give you 180 degrees. The three sides, and I had to change side A and side B. I had them mixed up. Remember, side B, the side is opposite the angle. So the capital B is opposite the lowercase b. Same thing with A and C. Side A's value is 6. We're looking for side C value and side B's value. Now, we know that this one right here, we just found out that this one right here is 28 degrees. And we know we didn't make a calculation error, but it's a good idea to not use 28 degrees in your calculations for the simple reason is, what if you just made a mistake? What if you did 2 and 8 together, but instead of putting 28, you put 38? Just because you forgot to carry it or borrow it or whatever you had to do. So just to eliminate making a second and a third error, always go back to whatever value is given to you. The given value was 62. So use that perspective every time because you have to pick one of them anyways. Just pick the given value. So we have 6 as a value. If we want to find B's value, when we look across from 62, that's the opposite. And we have 6. We have to use 6 because we can't use C because we don't know what it is. So we have to use this 6, which is the adjacent. So we have an O and we have an A. The one that goes with O and A is TOA. So the tangent of 62 degrees is equal to the opposite B divided by the adjacent 6. So in order to get B's value by itself, algebraically, we know how to do that. It says divided by 6. We multiply by 6. So when you do it there, you do it here. So 6 tangent of 62. And again, that's one of the first 3 trig functions. 6 tan 62. And when I do that, I get approximately 11.2843, and it keeps going. Again, without directions that tell you otherwise, round to the nearest hundredth. So I would get 11.28 for that one. So B's value then is 11.28. And again, don't do what I did a minute ago and get them mixed up and write it in place of C, because you'd have done all of that work and you would still get it incorrect, having different sides or having in the wrong spot. Now, since we now know that B's value is 11.28, or this one right here is approximately 11.28, that's a good calculation. But again, just like we don't want to use 28, just in case we made a mistake, don't use 11.28. Not just because it is an estimation of 11.28 and not an exact value, but also what if you made a mistake? So again, from this perspective, 62 right here, take C's value and again take 6. So what do we have is 6 is our adjacent, and what do we have as C? That's the hypotenuse. So ka toa. So again, those are the ones you want to use till you're familiar with using the secant and cosecant and cotangent. But the only one that uses an A and an H is the cosine, or the ka part of that formula. So the cosine of 62 equals the adjacent 6 divided by the hypotenuse C. And this is one, when you become more familiar, this is one of those formulas where it would be better for us to use a different, it would be better for us to use the secant, because then that would give us C over 6 instead of 6 over C. But before we do that, though, it's probably easier for us right now to use the formula we know. In order to get C by itself, it just takes us 2 steps instead of 1. This says 6 divided by C, multiplied by C. Now what we have is C times the cosine of 62 equals 6. And then to get C by itself, you have to undo one more step, divide by the cosine of 62. That'll leave us with just C. So if you do it to the left, do it to the right. This is what I meant about using the secant instead of the cosine. But it'll work just the same doing it this way. It just takes you one more algebraic step, which most students would probably prefer to do it this way than to have to figure out a different trig function. So simply 6 divided by the cosine of 62 degrees. And when you do that, you're going to get C's value. And again, it's 12.780. It keeps on going. So that's an approximation. If you're given if you don't give instructions on how to round it, simply round it to the nearest hundredth, and we'll get C's approximate value at 12.78. Now, one more thing you want to check when you're solving a triangle. If you look at all three sides, if the hypotenuse, in this case C, is not the longest value, you know something's incorrect with your graph or with your picture. You did some kind of calculation wrong. Also, if you add A and B together, it has to come out to be longer than C. So if we add A and B just real quick, 6 and 11, we know we get the number 17. That's bigger than 12. So that's just something quickly you can check to make sure that you probably made correct calculations for this. So this is considered a solved triangle. All three sides and all three angles are solved out. Example number 3 says you're measuring a flagpole or the height of a flagpole. You stand 20 feet from the base of the pole. You measure the angle of elevation. Again, remember, elevation goes up, depression goes down. From a point on the ground to the top of the pole to be 65 degrees. So you can see that angle 65 degrees. Estimate the height of the pole. So the height divided by 20 is equal to the tangent of 65 degrees. Okay, so again, from this perspective here, what is H? What is the height? And don't get it confused with hypotenuse. Oh, it's opposite 65 degrees. And what is 20 feet? It's adjacent. So you have O and you have A. Remember, that's the one that goes with TOA. That's why we use the tangent of 65 degrees. The tangent of 65 degrees is approximately 2.145. So 65. So what we have now is H divided by 20 is equal to the tangent of 65, which is 2.145. To get H by itself, you multiply both sides by 20. That's just doing simple algebra there. When you do that, you get a height of the flagpole of about 43 feet. And again, that's an estimate because that's an estimate of the tangent of 65 degrees. That little wavy equal sign means approximately 2.145. Okay, this one right here on the back, real quick. You're flying a kite 4 feet above the ground using 300 feet of line with a wind speed of 40 miles per hour. The angle the kite line makes with the ground is 29 degrees. How high is the kite flying? Draw this. Don't copy it. Draw the scenario. It is much, much easier than it appears. Much easier than it appears. Draw it. You know it's going to be a triangle, so draw a triangle. Draw the triangle first, and then we'll solve it. What number are we not going to use? There's 4 numbers up here. We absolutely have to use 300 feet. 40 miles per hour is going to be an irrelevant number because 40 miles per hour is making the 29-degree angle, but we already have 29-degree angle. So if your triangle looks like this, This is where you're standing right here, 4 feet above the ground. Remember, that's 4. You have to include that at the end. This is the kite line right here, 300 feet. This is the angle, 29 degrees. So we have two angles and the side. Do we have enough to solve the entire triangle if we wanted to? Angle, angle, side. We absolutely do. We don't want to solve the whole triangle, though. We simply want to find out how high this kite is flying. We want to find out what x is. So we're trying to figure out how high the kite is flying. In this picture, we're trying to figure out how long is x. We have two angles and we have one side. We have that kite string at 300 feet. So from that 29-degree perspective, from that perspective right there, x's value is the opposite. 300 is the hypotenuse. So remember, Chief SOHCAHTOA tells you how to do this. SOHCAH and TOA. The only one that uses an O and an H is the sine. So the sine of 29 degrees is equal to the opposite, in this case the height, x, over the hypotenuse, 300. So this is one of those formulas where it actually does help us to use the older trig formula, sine. So because we only have algebraically to do one step. It says x divided by 300, you multiply by 300, and when you do it to the right side, do it to the left side. So that'll give us x all by itself, and it'll tell us how high that triangle gives us, and then we just simply have to add 4 feet to it. So 300 times the sine of 29 degrees. We get, for our x value, I'll write it right here, we get 145.44 feet. Now, x is 145.44 feet. The question that it asks you is how high is the kite flying? 40 miles per hour was the one number in the problem that was unnecessary because you were given 29 degrees. But since it's 145.44 feet, you have to also include the fact that you're holding the kite string 4 feet above the ground. So that's why you have to put those two numbers together. 145.44 plus 4 is 149.44 feet. And that's how high above the ground that kite is flying. So even though most of you will probably never do anything like this in your real life, you could theoretically solve how high that thing's flying. When your kid is flying a kite one day, you can find, you say, man, how high is it going up? You could actually figure it out. Again, I know you won't, but you could. So when you, before you raise your hand, say, Coach King, when are we ever going to use this stupid stuff? Right here. But you probably never will. But if you wanted to, you could. This one on the checkpoint tells us to solve this triangle ABC. Solving a triangle means 3 sides, 3 angles. We have 2 angles already. That is the easiest thing to solve. Then is the third angle. Remember, B's angle is going to be complementary with A's angle. That means together they make 90 degrees. So what number do you have to add to 34 to get 90? It's not 66. That would give you 100. That's a very common thing people do. They say, okay, well, 3 and 6 is 9, and 4 and 6 is 10. So no, you're trying to make it to 90, not to 100. So it's not 66, it is 56. So this one right here, 56 degrees. That's the easiest thing to solve. But again, don't use 56 degrees just in case you wrote 66 by accident. That will throw every calculation you have off. Use 34 degrees to solve the 2 sides. A is the opposite. C's value, we got to use 24 because that's the given, is the hypotenuse. So you'll set that up as the sine of 34 is equal to the opposite, A, divided by the hypotenuse, 24. This is a simple problem. One step to get A by itself. Multiply both sides by 24. If you do it there, do it here. So 24, that'll cancel out. 24 sine 34 will give you exactly what you need. So A's value then is approximately, and I'll just write it on the side right here, approximately A is 13.42. That's how long that side is. In order to solve C's value, again, we don't want to use the O anymore. We are going to use 24, but now we have not the opposite. Now we have an adjacent. So the only formula that uses an adjacent and a hypotenuse is the cosine. The cosine now of 34 degrees is equal to B over the H, 24. And again, to get B by itself, we multiply both sides by 24. Do it there and do it here. This cancels and gives us B's value. Notice these calculations, even though it seems like a lot of work, these calculations become very repetitive when you solve them for a triangle. Instead of hitting 24 sine 34 this time, now we're hitting 24 cosine 34. And when you do that, you get B's value at 19.896, which means 19.89 would go up to give you 19.0. And it'll be 0, 0. So that's an approximation as well. So now this triangle is solved. All three sides and all three angles are represented. Excuse me, it's actually not, it's not 19.0. I lost the whole thing. You round to 19.9. It would be 19.90. That's the zero I was thinking. 19.90. And then this one, here we go. A cable to a radio tower makes an angle of 64 degrees with the ground. If the cable is 240 feet, how far above the ground does it meet the tower? So you have to make a couple of assumptions right here. The first thing you have to make an assumption is that the pole is going straight up and down. It's not on any kind of angle. So it's creating, the pole itself is creating a 90-degree angle with the ground. It says a cable to a radio tower makes an angle of 54 degrees. So this angle here is going to be 54 degrees. It says if the cable is 240 feet, this is the cable here. If it's 240 feet, how far above the ground does it meet the tower? So you have to logically think about what's going on. You can't just be a monkey and punch numbers right here. What's going on? Where? What is it asking you for? What value? Is it asking you for this one, or is it asking you for this one? Which one? It's saying how far above the ground does it meet the tower? First off, think about where the tower is and think about where the ground is. The ground's at the bottom, and it's going how high up the tower. So it's asking you for this value right here. We'll call it X where nobody gets confused. That's the one we're looking for, though. So from 54 degrees, what would we call X? Would we call it adjacent, opposite, or hypotenuse? That's opposite. And what would we call 240? Hypotenuse. So, which of our SOHCAHTOA formulas use opposite and hypotenuse? Sine, that's right. So the sine then of not 54, 34, 54. The sine of 54 degrees equals the opposite, that's our unknown, over our hypotenuse, 240. Very simple. Get rid of, divide by 240 by multiplying both sides by 240. And again, feel how repetitive all of this feels. X then is equal to 240 sine 54. And we're going to get that value as 194. It tells you to round to the nearest foot right here. Notice the directions. So 194, we're not going to round up past that. 194 since it's 0.1. So that's how high the cable is meeting the pole, at 194 feet. And again, if you look at this, it's the exact same problem as flying a kite. It's the exact same problem, just with different numbers, and it's explained as a different scenario, but you're using the same the same sides and everything. We took the sine of the opposite over the hypotenuse for the kite one. We're doing the exact same thing with this cable problem. Same thing.